Good morning, this is Hallicrafters Rehabs. Welcome back. So, one thing I always do is document everything I do on these radios, and hopefully the documentation stays with the radio and people can figure out things without having to guess. And one of the things I do is on the order list or the parts list, I will indicate what has been replaced and what is not, and when it was done. So, for example, with capacitors, then you could see that it was replaced in 2016 or in 2020, and then at some time in the future, then you have an idea of whether or not you need to check them to see if there's leakage in them, or with the electrolytics you can actually have a recommended service interval of checking your electrolytics every 5 years or replacing them every 10 years or something like that. So you know what to expect. And so, can you imagine this radio? And after 30 years, you might have want to check the resistance values. So, can you imagine this radio lasting 30 more years? Well, it can, if it's not stored in an attic or in the barn or the garage. And if it ever does get there, I will come back from the grave and hurt whoever did that. At any rate. But the other thing it does is it's another check. And yes, lo and behold, this resistor that's across the phono input is a wrong value. It was a wrong value before, and instead of checking first, I simply replaced it, but it's supposed to be 470,000 ohms. So I'm going to take care of that, and then it'll be ready to do some resistance checks, DC resistance checks. Well, this is also a good time to put in the rectified filament 7 volts that we'll use to do an instant on digital display for this. It's very simple. It's in Mr. Carlson's lab, and I think it was build a buffer circuit or something like that for one of his HQ 140 restorations, but it's very simple. Just take the filament, lead, the green lead, bring it around to a 22 ohm resistor. This is actually a 2 watt resistor. A Schottky diode, 0.01 capacitor across it, and then a 2200 50 volt electrolytic, and then you've got a nice rectified 6.3 volt DC for your digital display, or maybe if you want to put in a Bluetooth, and you can use that for that. So I do this pretty much all the time now. So I'm going to put this in. Okay, so I've installed this rectified heater. It comes into here and comes out. It's actually, I put the components in the wrong order, but that's okay. And then the DC goes through this highly convenient hole right here in the chassis under the filter box. So we are indeed ready to do the DC resistance check. So I'll have to turn it all over and set things up. So what I'm doing now is I'm going through each pin on the tubes and the tube sockets, and I'm measuring the DC voltage. There's 2 places you measure against. One is ground for anything that's not associated with B plus or the screen voltage. And then pin 8 or pin 2 of the rectifier tube is against the measurement for usually pin 5 and 6 on these 7-pin tubes and so forth. So if it's associated with the, I've got a symbol there that says if it's associated with the B plus or the screen, then that's actually screen and that's B plus. Then that's the measurement that's taken. So I'm going through, and thus far all the measurements are good, and we'll just continue on until it's finished. Okay, after a break for 2 days with my father and doing some other work that I had to get done, I completed this form based on the measurements that I took. The blue is the as left, the red was the as found. Some of the values in the red sort of leave question as to whether I did a very good job on that. I'm not sure, but at any rate, I've gone through all the discrepancies and have satisfied myself that everything is as it should be in the reconstruction of this radio set. Particularly, I was very interested in this 6BA6. That must have been an open connection or something like that on pin 2, hard to say. 22K was 564, and we saw toasted resistors and all kinds of stuff in there. So just made sense to go through and here's 140, that's supposed to be K up there, but that's 141K as opposed to 103K. I'll make those changes. And things like that. So this could have been a misread actually on the original. So all of the blue has been verified against the schematic as well. And so we are ready to proceed, and I'm really thinking the next step is to put the face on. That adds a lot of more weight, makes me struggle more, but I think that's the next step, and then we will test the tubes and particularly go through, look carefully at the 6BA6s, because one of them was in this distressed position before this thing was restored. I'm not going to go through on camera the placing of the face on. Just remember there's a sleeve that goes over this pitch control. I did this on the Mark I in great detail, so there's no need to repeat all those videos, but we'll get these knobs taken off and the right ones put on, and get that face put on, and connect up the S meter and the lamps. And then we'll, after testing the tubes, we will be ready to start the voltage checks. I did put these discs on, and one thing I need to mention is there's a couple of, on this patent pending assembly here, maybe they have their patent, there is a two adjustments that are useful. One is you take the screwdriver and you push this and disengage this, and with the condenser or the band spread, or if it's a main tuning, at one extreme or the other, it's not at either one right now, but let's say it's right here. Okay, that's at the end of the travel right there. Okay, you want the end of the travel, and you want it to be straight up. It looks like it's not, so maybe it's my angle. Let me try the camera a little better. Move my flashlight out of the way. can see it. Okay, that should be straight up and down. Easy to do. You just push this up right in here. And that, oh, yes, there's one other thing. Almost forgot that part. This is an adjustment that kind of locks it down and also tensions it for the kind of, this screw right here, it tensions it for the kind of how much resistance you want that knob to have. Right now you want it completely loose so that we can do this. So we'll move this up. Wait a minute, we got to get to the end here. Okay. I want to move it up some more, so I'm going to just make it really loose. I hope it doesn't fall on the floor. You push up here. There you go. And it's almost disengaged. Here we are. And you can rotate that freely to where you think it's, you can do, this is really a rough adjustment at this point. It's just at the, you may have to make a slight adjustment when the thing is, that you want it vertical. I think that's vertical. Still looks like a little bit of a slant. Well, I used to have a Tsquare, and that shows a little bit of an angle there, even though it's not centered. I can't get it over this way far enough, but I can eyeball it a lot better with this. So we'll just lift this up, do a tiny adjustment there. It's supposed to be at the maximum travel. I don't know what happened to that. Okay. So, still slipping when I adjust it. Oh, I see. Yeah, it's attached to that, of course. So, what we have is this part needs to be adjusted. And there is an adjustment for that, which is a set screw. Two of them. I have to get the right hex. So on the spindle in the back there's a hex. Well, it's two hex nuts. I think I need to get the other one adjusted and done first. And it's behind this disc plate. And this will take some time. So the hex nut is right here. I'm waiting for the WD-40 to sort of do its work here because it's kind of frozen in position, but we loosen that and then we can turn this with respect to the pulley, which is actually engaging the band spread, so I have to wait on that. It's all a matter of waiting and the use of this. I call it a $20 Hallicrafters tool. Is a special hex that works on Hallicrafters. It's really a form of star with 4 points. And this is the smallest one. And it's the only one you can find. Comes in a set of a whole bunch of other ones you really don't need, but this is the one you need. I need to paint it red or something. Anyway, waiting on WD-40 and that. Okay, so I have the condenser fully meshed. You lift that up till it's disengaged, and you bring it to vertical, just like that. And where did that 90-degree thing go? That was not even eyeballed. Okay. I'm going to have to use my flashlight here. Alright, it's uneven, of course. And it's still a little bit tilted for some reason. Boy, it doesn't look that way to me, but it is. Alright, let's see what that does. My eyeball here. Man, it's loose. Okay, don't do it from there. Where's the end travel? Okay, not even close. Screwdriver is gone. I think what's happening is I'm actually turning, I haven't really loosened that enough in the back. It's actually moving the, no, it's not, okay. Alright, now let's try. There's another trick to this I missed. Yes, there is another adjustment on this side, which is where the stop is. And the stop is in a different position than where it should be. So, see if I can, yes, that one comes loose. There's 2 of them, of course. There's enough adjustments on this. Okay, that one's loose. Good. Alright, so the stop is here. Actually, I made it too loose now. I gotta tighten it down. So this is going to take some adjustment. Let me just lift the camera here and show you the stop. Alright, down at the bottom here, that's the stop. There's an adjustment here and there, and you can rotate this with respect to the stop to get the 0. So I've got to adjust that, that, and that. So that'll take some time. I did not get this right on the Mark I, so when I go back and tighten this and some other things, I'll take care of it. But first, step 1, put a knob on here so your fingers don't come off. Then step 2, loosen the 2 set screws on the pulley behind here and then on the cam for the stop. Step 3, run it to the end of the, oh no, what's happened? Right, run it to the end of the capacitor. Then with some kind of tool, and it still looks a little bit off now, we may have to adjust it again. You want it vertical. Okay. Then you tighten the pulleys in the back so that it is vertical when the band spread is fully meshed. Then you Then you move the stop cam around with it loose until it just stops the turn of the dial at this point. And that's almost at the very tip of the cam. And then tighten it down, the 2 screws down from there. And yes, now then this is really loose, so we're going to adjust this down to increase the, that's about like the way I want it. So now I have to do it for the other side. Man. Okay, on this side there was nothing to do. It's the same arrangement where you have to loosen the cam, but it's directly on a gear, and you also loosen the pulley or sprocket actually that turns the main tuning condenser. Since that wasn't a dial that was restrung, it's the same as it's always been since the factory. Now that I say that, yes, and it's vertical right here. So both ends are vertical at the fully meshed main tuning capacitor position. Yay! Okay, so I got the lower knobs in, and now what has to go in is this part, this up here, and this knob over here. And it always takes a lot of time. I spent some time polishing up the knobs a little bit too, and then indexing this to the dial indexes, as well as this area was very difficult to get in because it's just a very tight area to get behind there, and you generally have to adjust the nuts behind these switches so that it'll come out far enough to grab the nut on the outside and tighten it in. So we'll work on getting the remaining controls in, and then we can test the tubes. Okay, so I got the knobs on, and there was really nothing remarkable about it, just time consuming. This you want to have travel. There is a set screw that is a stop, and so you want it on the 50 when it hits it on this side, on that side, and then you want it on all the way, the travel all the way this way when it's on that side. And then this is the off, which allows you to adjust that, the off on. So next step is to connect up the S meter and the lighting system in the back. So this was put in. They're LED lights. They're gaming machine LED lights. There's better stuff to use these days, but I didn't know what to do back then. But this is for me, so someday I can take all that out and put the other stuff back in if I want to. So it's connected up, and this is the S meter. A negative's on the left, the blue. The red goes to the positive. And this little piece of cardboard is kind of hard to take care of. It tends to split right here when you take it out. So I just use a piece of masking tape is enough to hold it together. It's to keep you from accidentally coming across B+ voltage. You can call that early product liability concerns. At any rate, everything's in but the tubes, and so that's the next step. Okay, correct. I'm at the tube testing stage, and there are hundreds of videos out there on how to test tubes and things like that. This is an old one, a teletest. I bought it old, model T56. It's the only one I have. Actually, the tubes that I'll be testing in this, this Mark 1B were hand selected from my inventory for the best, because I didn't have a tube tester back in 2017. I just used the radio as a tube tester and selected the tubes that gave me the best result. So that's the way I'm going to handle that. This one, it's got an odd looking dark side on here. It's a 6CB, it's V1, it's an RF amplifier, 6CB6. So I will test this one right now. And the 6BA6s, I'm going to be going through all of them very carefully, because the 6BA6s, one of those had the burnt out or separated screen resistor, and I have a theory behind that as well. I'll talk to you about that when I get to that tube. So let's see, what we're going to do is just the setting for 6CB6 is socket 7, section 1. Okay, filament A, and we're just going to heat it up for 30 seconds. So all of these tubes have been in an operating set. It doesn't do anything, it just tests emission and that's about it. And for a short, it's not a calibrated by any stretch tube tester. So we check for gas, no. And we'll go back to the line adjust. And let's see if it tests. It's still testing 100 plus, so I can't argue with it. Doesn't look that great, but it seems to be doing fine, so we'll put her back in. So we'll just keep going through this one tube at a time. Well, surprisingly enough, there were no issues. Maybe it shouldn't be a surprise, but except for the fact that we had that one 6BA6 inside here that had the screen voltage wrong, but everything tested good. So there, all the tubes are in place. It's going to take too much setup today to start doing any voltage testing and power up. So we'll leave that to the next video. So this is a short one this time. It's mainly just going through the process of getting things back together. This is Hallicrafters Rehabs. Thanks for watching, and thanks for the new subscribers.